Catastrophic planet-wide tides flood cities. Pitch-black nights blanket the world, an ice age more powerful than any Earth has ever seen. Tungsten-shaded evening skies. This is what would happen if we swapped our moon with other moons in the solar system. And spoiler alert, you're not surviving most of these. Let's start with the truly titanic moon, Titan. You're used to our regular gray moon, but now, look up. That's Titan, a behemoth moon of Saturn, even larger than Mercury. Unlike Mercury, Titan is icy cold, minus 180 degrees Celsius or minus 290 degrees Fahrenheit. Its rivers and lakes aren't water, they're methane. And no, you shouldn't swim in them. Swap our moon for Titan, and Earth's nights would glow golden orange. Titan's 80% greater mass means stronger gravity, so tides would skyrocket. High tides would flood coastal cities twice a day. Erosion, destruction, chaos. Meanwhile, Titan itself would start to heat up in Earth's orbit. Methane seas would evaporate. Beneath its melting crust, a hidden ocean could emerge, maybe even home to alien microbes. But Titan's weak gravity can't hold that atmosphere forever. Over millions of years, it would bleed away into space, leaving a lifeless husk behind. Goodbye, hazy orange orb. Titan isn't the only thing that's cold and lifeless. Your career could be too if you don't keep up. Next up, Ganymede, the largest moon in the solar system. Twice as massive as ours, covered in bright ice that would turn night into day. But beauty brings destruction. Ganymede's immense gravity would unleash global megatides, devastating floods, quakes, and volcanic eruptions. Still, there's one upside. It would stabilize Earth's tilt, ending ice ages forever. As it warmed in our orbit, its 150-kilometer thick icy crust would melt into vast oceans beneath glowing auroras. A deadly, yet strangely beautiful new world. Next, Io, the most volcanically active body in the solar system. Its hundreds of volcanoes hurl molten sulfur into space, painting the cosmos orange. From Earth, you'd see eruptions with a backyard telescope. But once Io escapes Jupiter's gravitational tug, it would cool down. The volcanoes would fall silent. Our new moon would turn cold, quiet, and cratered, much like the one we started with. Europa, the smooth, frozen jewel of Jupiter. Beneath its ice lies a vast saltwater ocean deeper than anything on Earth. Swapping our moon for Europa would mean weaker tides and, over millions of years, a wobbling Earth tilt. That means climate chaos, massive ice ages, burning droughts, unpredictable seasons. But there's wonder here too. With Europa only 385,000 kilometers away, we could walk on its icy surface and search for life beneath the frozen shell. Maybe, just maybe, we'd finally find proof we're not alone. Triton, the largest moon of Neptune, is a cosmic oddball. It orbits backward, a retrograde rebel among moons. Brought to Earth's skies, it would still shine brilliantly, but its low mass means weaker tides. The sun would now drive Earth's tides, not the moon. Without a strong lunar anchor, our planet's tilt would wander, unleashing erratic ice ages and scorching epochs. At first, Triton's icy volcanoes would erupt, stunning plumes of frozen nitrogen. But soon it would warm, vaporize, and fade. The rebel would fall silent. Each of these celestial swaps paints a vivid picture of Earth's delicate balance and the profound impact our own moon has on our world. From golden orange skies to devastating megatides, these hypothetical scenarios underscore the unique role of our familiar lunar companion. That's right. Outside of Earth and Io, Triton is one of the most volcanically active spots in the solar system. Except it's not spewing molten rock, it's venting cryomagma from cryovolcanoes. That's just a fancy way of saying it's erupting ice, blasting plumes up to 8 kilometers or 5 miles into its atmosphere. We'd have a front row seat every night to watch our new moon-fired jets of frozen gas into space. Out by Neptune, Triton is so cold that its ice is made of frozen nitrogen, water, and methane. Its surface reaches a frigid minus 235 degrees Celsius. That's minus 391 Fahrenheit, one of the coldest places in the solar system. But once moved close to Earth, Triton would start to warm up. All that frozen nitrogen would vaporize, forming a thick, hazy atmosphere, maybe even a comet-like tail stretching behind it. Over centuries, Triton would slowly lose its icy shell, and if it hides an ocean beneath the surface, that too would fade. leaving behind a smaller, drier version of its once shining self. Still, in its early days, Triton would light up our night sky like no moon ever has. Icy jets glowing bright against the black. Unlike Triton, our next swap brings us two miniature moons, Mars's tiny satellites, Phobos and Deimos. They're so small, they might not even deserve to be called moons, more like captured asteroids. Phobos, the big sibling, is just 27 kilometers wide, about 17 miles. Deimos is even smaller, only 15 kilometers across. Both are lumpy, cratered, and completely irregular. If we swapped our moon for these two, well, paint the sky black. You'd barely notice them. Our nights would be nearly pitch dark, with only faint star-like dots flickering across the sky. Moonlight would vanish entirely, throwing nocturnal life into chaos. Good news for astronomers, but a complete disaster for the rest of Earth's ecosystems. With almost no lunar mass left, tides would be driven almost entirely by the sun. Oceanic tides would collapse, marine life would suffer, and coastal ecosystems would begin to die. Wind, waves, and global temperature balance would all spiral out of control. And it gets worse. Without a strong lunar anchor, Earth itself would begin to wobble wildly. Unpredictable seasons, ice ages, and droughts lasting tens of thousands of years. Imagine the North Pole drifting to the equator for 50,000 years straight. Over time, the planet's tilt would swing back and forth, rewriting climates and ecosystems over and over again. This could even end life as we know it, or at least trigger a mass extinction event. And here's the nightmare scenario. Phobos is slowly falling into Mars, about 2 meters closer every century. If Earth had Phobos instead, the same would happen here. In 50 million years, it would either shatter into rings or crash into Earth itself. That's a 27-kilometer wide asteroid impact, twice as big as the one that wiped out the dinosaurs. So yeah, extinction. Maybe not the best trade for our moon. Okay, let's give it one last try. The final moon on our swap list, Enceladus. A frozen ice ball orbiting Saturn's rings, but one with something extraordinary beneath its surface. Enceladus sprays icy water and gas into space, creating Saturn's outer E-ring. It's covered in fresh snow and pure ice, making it the brightest object in the solar system. If we swapped it for our moon, nights would shine a brilliant white glow. Beautiful, but dimmer than before. Still, Enceladus is small. Too small. Its weak gravity couldn't create the tides we depend on. Earth's coast would collapse into disarray, and our planet's tilt would again become unstable, just like with Phobos and Deimos. Over time, its icy crust would sublimate and melt, revealing hidden oceans beneath. Maybe even alien life swimming below. That would be breathtaking, but at a terrible cost to Earth's balance. In short, swapping our moon might sound like a fun experiment, but it would devastate our planet. Too massive, and tides would drown the coasts. Too small, and Earth would lose its balance, wobbling into climate chaos. So, while I'd love to watch cryovolcanoes on Triton or geysers on Enceladus, I think I'll stick to our good old moon. After all, it's the perfect partner for life on Earth, and the closest place in the universe where you can deliver a burger. But if you love exploring the what-ifs of our universe, don't stop here. Hit subscribe and join us.